Okay, so reusability we were talking yesterday, right? Reusability in the sense how to reuse the code actually. If you write any Java program or PL SQL scripting or program also or any scripting also, so how can you reuse? You can just create user defined function. You can call the function so wherever you want. We'll just reuse the existing code. Same way here also. In our case, code in the sense graph only. Okay, so your Abinitio graph type here usability. Right. So your Abinitio graph, right? Your graph uses main transformation logic will be stored in the Xfr file, Xfr file or Xfr object. Okay, so you have to understand how to reuse an Xfr. Okay, so which in term calls as embedding or calling calling a transformation within another transformation. So this type of coding also you will rarely see. If your project is using the complex coding, then only you will see this kind of code, calling a transformation within the another transformation. So this you cannot practice here, but I will show you whenever we are going to meet it, then I will show you in the latest version. But here um, calling a transformation with another transformation, right? So let us suppose you have an XFR, you have a reformat component. Okay, this is how you let the XFR, right? A reformat of in equal to begin, okay, and right. So let us suppose you want to create a user defined function. Okay, you can create some another XFR. So because I have one more XFR, my XFR name is called some concat.xfr. concat.xfr. So this concat.xfr where we are going to store in your sandbox or in your working area, right? Generally in the xfr folder. You know about xfr folder, right? So in the sandbox you can see some xfr folder. So there you will be storing your all transformation logic. So this can be included using a parameter called $a underscore xfr, because your $a underscore xfr parameter will be pointing to your sandbox path, your working area path. Your working area or sandbox contains MP, bin, XFR, and all, right. So this A underscore XFR will be pointing to your sandbox XFR path actually. Okay, you can either provide the absolute path or you can use the parameter also. Right, so I'm just calling the a parameter which will be pointing to my xfr directory path in my sandbox, that is called a underscore xfr. Since I am calling this as a parameter, I am including dollar as a prefix for this parameter. Okay, I'm just calling this xfr, right? So I can include this one actually. If you remember Java code, generally you will use some kind of import statement to import the packages. Okay, import you will use, right? In the same way here also, for reusability purpose you will use a statement called include actually. Include, you will use this kind of syntax. I will show you this, no worries, right? Okay, so we'll just include like this. So this is one transformation. In this transformation I can include another transformation. So this concat.xfr may have a function called concat. So let us suppose I am concatenating my input record. So out dot some output field test equal to, I can call the function called concat in dot some other field name I can give. Okay, so this is the user defined function actually. So this function I declared in my xfr concat. Okay, so like my concat is one file actually. This file contains a user defined function. This transformation was created in some other graph, not in this graph. I can include another graph transformation logic also, the current graph transformation logic, right? So this xfr file may have some user defined function called concat. I can call that function by including xfr on top of my current logic. I'll show you this, like I'm just giving some heads up only. This is what you can include the xfr. So in the interview point of view also, no one will ask you about this one. This is some advanced coding actually, that is up to you. You can just reuse the existing code or you can create the new code also. Okay, that depends actually. But in case If any of the project is using the existing code, whenever you are working in the project, you don't face any difficulty if you can understand this kind of coding. Okay, I'll show you this. Just remember. So my intention here is you have to understand. I can call an XFR from another XFR also. That is the only thing you have to remember. So this is a syntax to include another XFR in the current XFR. You can include this in our rollup component or scan component, join component, wherever you want. You can include the XFR. You can use these properties in your current XFR also. Okay, this is called reusing an XFR file. Okay, so I just remember this like the statement, include statement is enough. So we'll discuss about this. Like here, I cannot show you the practically. I'll show you when you meet me. Okay, so another thing is right reusing uh, reusing the components, the graph. So this is also called as subgraph concept. I'll show you the subgraph now. Okay, so I want to design a graph now. Let me open this.
హలో
Yes, Srinivas.
అంటే నేను మాట్లాడకపోయేసరికి నేను వినబడట్లేదు.
ఇది ఎంతసేపు రన్ అవుతుంది అర్థం కావట్లేదు నాకు. So I just want to like run the graph, but it is taking a lot of time.
ఓకే యాక్చువల్లీ ఐ couldn't able to then I thought of
No, no,
So even I thought machine stuck, my machine is stuck or something.
no. Okay. So we are going to discuss about subgraph concept now, right? So let it run. Meanwhile, I will give some theory about the subgraph. So these subgraphs we can practice here, but you will see many subgraph in your projects. The purpose is different actually. Introduction, why the subgraphs were introduced. The purpose is different, but nowadays it was being in different purpose actually. So everyone will think like if you have like 40 components in a graph for an instance, so I cannot see all the uh, components in my canvas. I'm not able to check all the graphs. So there are some there are some components which never cause any issue, not which never cause any issue. So like slot and some other components. Those components I don't want to display on my screen. I want to just fold them as a subgraph. I want to fold them as a subgraph. In that case, generally what we will do is you will just highlight the components whatever you want and select the components. I mean highlight in this and select the components whatever you want and then make it as subgraph. This is what we will do generally. But the main purpose why the corporation introduced is for the reusability purpose. Reusability in the sense you can highlight the components whatever you want, make it a subgraph, save that subgraph with some other extension dot mpc. MPC stands for programming component. Your dot MP means your graph, right? Generally, dot MPC. If you save any object, that means that is called user-defined component. If you remember in our architecture, I told you, Judy, you can use the existing components from the component suite, and you can also create the user-defined components for usability purpose. Okay, so in the same way, you can come on you can create the different component. So now let me enhance this graph first. Let me include one more component here. For the summarization activity, I want to include roll-up component here. Okay. Total amount I am taking. The keys. Okay. So let us suppose I want to let me make the in-memory option. Right. I want to make these entire thing a subgraph. Let us suppose I just want to show you how to create the subgraph only, but it doesn't mean always you will work on the subgraphs. So if you have a big graph, actually if you have a big graph, you want to just create a subgraph in the graph, you can create. I want to show you the first purpose now how to create this as a subgraph. Okay, highlight the components whatever you want, in your latest version, which is 3.0 or 1 or 2, there you can right click on the highlighted components. You can see one option here. uh, make it as subgraph option. So you can see one option here, create from selection option. Also you can say, I think, create from selection from the latest version. So it will create a subgraph actually. So now in this version we don't have that option. That's why I want to go for view edit menu, because this is another way to get the subgraph, another way of selecting subgraphs here. So here click on edit, click on subgraph, click on create from selection. Okay, so then it will ask you a name for the subgraph, because your subgraph will be displayed as the component only after the subgraph creation. So you have to provide a name for the subgraph. Standard is, so you can give any name, that is your choice, but the general the standard is SG. You have to give SG means subgraph hyphen join customers. Click on OK. You can see subgraph here. This is called a subgraph now. Okay, so now your graph looks very simple. So this is one purpose. Generally you will use this purpose only. So most of the guys will use the graphs subgraphs for this purpose only, in order to make the graph in order to make some cosmetic changes, and in order to make the graph very simple to be understand. You can see that. So what you have to follow is in the subgraph you can identify easily this subgraph is doing some join activity with the help of this label only. If you want to see the code, open the code, double click on the, you can see the a subgraph like this. Okay, a subgraph also can contain the ports. Let us suppose there is a unused port, reject port, and already if you want to capture unused records also, you can capture. So there is a menu, right? So show optional ports. Click on this tool, it will show all the ports. Let us suppose you want to capture unused records. Okay, so unused ports you can capture like this. Just drag and connect to the edge. Close this one, right? You can see the ports here. Okay, so my intention here is I wanted to make you understand a subgraph can also contain the ports like your component. So now this is called as a component fragment, or this is called a component only. So you can create this is called user defined component. But now for usability purpose, you have to use the same component n number of times in n number of graphs, right? If you want to use this one, you can just copy paste also. Copy here, paste in some other graph also. That is a shortcut. Or what you can do is you can create a user defined component now. So open this one. Sorry. Open this subgraph. Go to file menu. Click on save as option. Okay. So right, we can save this as a user defined component now. I will show you how to save. Click on save as.
So where do you save in sandbox?
Yes, sandbox only.
Means
Everything
specific
will be
location.
sandbox only. So in the sandbox, if you want to go with the user defined components, like as of now, very rare projects only you can see this kind of user defined components. If you want to create the user defined components in your project, so what you have to do is you have to create a separate folder in the sandbox. You can save anywhere, but the standard is in the sandbox you can save in a separate folder. So I want to create the sandbox in C drive. Test is my sandbox. Okay, so now in the C drive you can see the sandbox, right? Okay, so in the sandbox here you can see all the folders. So create a new folder for you for your user defined purpose. Okay, I am creating a folder called components, user defined components, right? So components, I want to store the user defined components. You can create any number of folders like this. Okay, open this one, file menu, save as. Okay, save as, and wait. C drive. Show is test. Components, right? Save this as inner join dot mpc. You have to say, not mp, mpc. Okay. So now this is the extension for the user defined components. Now this is called user defined component. Save this one. Okay. So now it will be saved in the components folder, right? So you can see the sandbox view actually in the latest version, the right side of the your GDE. So how you are able to see the component organizer here in the same way, you can see the component suite. Okay, you can see the component suite in the right side, right? The component suite, how you are able to see the component suite in the same way, you can see the sandbox view in the latest version. Okay, in the sandbox we can see the components folder. There you can see inner join dot mpc component. Okay, so now if you want to insert that component, you can insert also. Go to insert menu, click on there are program component. Click on program component. So these are called built-in components, right? So I want to switch to my user defined components. C drive, test, components. You can see the diagram. You can see the icon, the component symbol, right? Click here. It will display as the user defined components in the latest version, but here it won't support. Okay, let me take the new graph. Since it is opening here, it is not allowing to insert again. I don't know why sharing violation is happening here. Let me try here. Not opening. The latest version it will open. Okay, it is showing sharing violation here. Let me try once again. I'm closing this one. So now I will insert program component. Yeah, inserted, right? Oh, this one inserted. This one only, right? Okay. But I didn't give the join name, right? Why it is taking join name? Oh, oh, it was entire graph was saved actually. Okay, generally in your version only the subgraph will be saved, but not entire graph, right? So now this can be reused here as a subgraph. Okay, so this is what you can create the subgraph. You can create the user defined components as well with .mpc extension.
Nested subgraph is also possible,
Possible,
right?
yes.
This is
This is
nested
also,
subgraph, right?
yeah. You can highlight the components, these two, go to your edit menu, click on subgraph again. Nested also possible. Okay, right? Nested also possible. You can create nested subgraphs also. Okay, so now this is what you can reuse the components within the graph actually. But I want to show you now how to make a graph as generic graph, right? So you might be heard about template classes in C++ or generic graphs, generic classes in Java language, or template classes we'll call generally. Same class can be used by passing the parameters. Same way here also, same graph can be used actually. Okay, same graph we can run for multiple times. So before talking about this generic graph, so I just want to check with you, like, what is the purpose of the reusability in the graph. Let us suppose I have a requirement. Okay, I have like 20 sources or 20 branches for my bank. I will be receiving 20 files on daily basis. all my 20 files will have 20 kind of transformation. 20 output files I have to create, or 20 output tables I have to load from these 20 input files. Right, you got the requirement, right? Read multiple files, apply the multiple transformations on the multiple files, load this data into multiple files or multiple tables. Okay, so now if you want to, okay, so if you have to fulfill the requirement for these 20 types of sources, you will think like 20 graphs I have to design. Okay, 20 graphs I have to design, right? Because on this one, right? Yes, because generally how we'll think so 20 files I have to use 20 input file components, 20 reformat components, 20 join components, 20 rollup component, 20 output file components in 20 graphs I am talking. Instead of going for the 20 graphs like this, you can use a single graph for 20 times also. Okay, so instead of passing the parameters, instead of passing the file name here, you can parameterize this one. Just parameterize the input file path, parameterize the DML path also. DML also you can parameterize. Okay, and join Xfr also you can parameterize. Right, this transformation logic parameterize. Okay, and roll up key you can parameterize. Roll up transformation you can parameterize, and output file path also you can parameterize. Right, so you can pass the parameters in the file actually. So what you can do is you can parameterize the graph, pass the parameter values at runtime. Okay, so then you can reuse the same graph 20 times. Right, so now I want to create the parameters. Now we'll discuss how to create parameters. Okay, so you know what is the parameter, right? Generally in all the language we will use the parameter. Parameter is a kind of variable only, but we will pass the value for the parameter at runtime. Okay, so we will discuss how to create parameters now. Right, so now let me copy this path, because this is my, I want to parameter this one, right? Let me list down all the file path. Input file 1. Okay, this is input file 2. This is giant transformation, right? So giant transformation, giant key also you can parameterize if you want. Giant key, giant transformation, right? So this one I want to pass at runtime. Let me save this as a file, transformation logic. Okay, where is my test sandbox? Xfr.
In real time, in new Abinitio, in latest version, every time we have to save, or it will be auto saved in that Xfr?
No, we have to provide the file name, right?
Okay, like every time the transformation we have to provide, and we have to save it in the sandbox.
Yeah, sandbox. That is your choice actually. If you want to embed, you can embed. You need not to save in any file each and every time. So if you want to save, you can save. That is standard actually. The standard is generally better to save everything in the file. So if there is any change also from the back end also you can change without opening the GDE. So if you can save everything in the file system, right? So
Okay.
if you don't have GDE access also in the production also, if there is any some cases like there are any emergency cases where you may have to modify the XFR in the production without having the GDE also, you can open the file using VA editor or cat command. There you can edit however you want. That is not accepted general, but I am just saying like if you can save in the file name. Okay, otherwise you
Okay.
can save in embedded code also, open the graph, modify whenever you want. That is up to you
Okay.
actually. So based on your requirement you can write the code, right? So
Okay.
if you don't have any reusability concept in the project, you can embed you can embed everywhere in the graph. If you have the reusability concept, then only you have to, okay, then only you have to save in the file. Let us
Okay.
suppose I want to reuse the same XFR in n number of times in n graphs, n joined
Okay.
XFR. Okay, then what I can do is I can save in the file. This file I will point to in another graph also.
Okay.
If you don't have reusability, you need not save actually. You can just put it as embedded code only. If you see here, I am automatically it is pointing to file now because I saved as a file. It is pointing to file now. C:/test xfr / inner join xfr. Okay, the same path I can give some other join component also in some other graph. That is called reusability of the
Oh,
existing xfr, right?
okay.
Then you can save.
Okay.
Otherwise, you can leave as embedded code also. Okay, so now because uh, I want to just pass through a parameter, right? Through a parameter, you cannot provide the complete code, right? Like your embedded code, you cannot pass through a parameter. That's why I'm saving in the file. Okay, I saved also the join xf also I saved, and the next one is roll up, right? Roll up xfr also I want to save. File menu, save as, test xfr roll up. You can see now it is pointing to roll up xfr after I save. Okay, so copy this one as well. Okay, save this one. So this output file also have to parameterize. This one also have to parameterize because the same output I cannot use all the sources. Okay, parameterize. So now I have to provide the parameters here. Okay, so let's talk about the parameter names now. Okay, so for this data file, I want to create a parameter called in0_file. A parameter name, I am just assuming a parameter name. For this one, in1_file. For this key, this is a join key, right? Or I am calling this as a group key, and this is join xfr, right? So let me create a parameter name called join_xfr, and this is roll of xfr. Okay, roll up underscore xfr. uh, this is out underscore file. So you can give any name, that is your choice. So just to understand the uh, like the purpose of the parameter, just to define a name here. So if I see this value, I can understand the purpose, right? In0 file means input 0 file path. In1 file means input 1 file path. Okay, just provide some meaningful names for the parameter, whatever you want you can provide. I'm opening graph now. Since I want to parameterize this graph, you should not provide any hard coded value here. So first value I am providing is input file path here. This one I should not hard code. Okay, so I have to provide parameter name here. My parameter name I want to declare here is, I want to provide here is in_file. Okay, so before providing the parameter name here, you must declare the parameter first. So here this is called calling the parameter, right? So before calling the parameter from the graph, you must declare the parameter definition first, right? To declare the parameter definition, okay, so go to parameter menu. I will show you how to create the parameter now. Okay, go to edit menu, click on the parameters. Where is this? Where is this? Where is this? Where is this? Yes, parameters here, right? So the shortcut is F11 actually. Generally we will be using shortcut, right? So edit pin and all we don't go. You can press F11 key as the shortcut, or you can click on the edit parameters. Parameters, you can see a parameter editor. See, this parameter editor is somewhat different from the latest version parameter editor. I'll show you that as well. Okay, here this is the old version editor actually. The look and feel is different in the latest version. Okay, but the way of declaring using everything is same. Declare your parameter name here. Okay, so you can see the existing component names here. Join is the graph name, and the output file is the output file component name. As is any subgraph name. Rollup is rollup component name. You can see the built-in parameters. All these are called built-in parameters for this graph. We don't touch this one. Okay, the user defined parameter you can create using place the cursor here. The first parameter name is in0 file. Copy this one. Okay, paste here, right? So data type, so which value you want to store in the in0 file, whether you want to store the string value, decimal value and all, you can select the data type here. I want to store the transformation logic, sorry, I want to store the input file path. The input file path is URL, right? URL you have to select. URL means the location of the input file. Okay, input file path you have to provide. URL means, right? So location is optional thing. Location in the sense you can give graph or something else. Location is optional, you do not provide any value here. Value you have to provide in the value column. In the value column you have to provide the value of this parameter. My value of this parameter is this one, right? So copy this one, copy the entire thing. Okay, edit. You can also browse or you can paste like this, right? You can give any path. I am just parameter. This is the existing built-in graph actually. That's why they stored all the examples in the AB home actually. That's why you are able to see the AB home parameter here. Okay, the AB home they saved the file actually. You can give any name here. Your source path you have to provide in the value. Okay, description you can provide any description. Something like parameter stores input path. You can give any description. Okay, we'll talk about required later. So what is this required? There are two options actually. You can either read this parameter, or you can ignore the parameter also. Optional parameters are the required parameters. So this is required parameter. We'll discuss about optional also. Okay, again we'll discuss about this option required and all. Now this is first parameter. Similarly second parameter also. Okay, open the graph. Second parameter value. So this is also URL, right? Give URL and path of this parameter, third parameter. So like this you have to declare all the parameters. Okay, parameter value, provide the path. So generally value you need not provide the value actually. You can ignore this value also. So this is key specifier, right? Select the key. This is key actually. Select key specifier, provide the key name here. Okay, generally value we don't provide actually. Parameter name only we will declare. Okay, so value is optional. I will tell you when I have to provide the value, when I need not provide the value. Okay, so let me paste the values first. I will discuss about that as well. Join Xfr is another parameter. This is transformation logic. I am providing through a URL only, a file name only. Okay, provide the file name here. Okay, role of Xfr. This is also URL. Provide the role of Xfr file. Out file. Paste this URL. You can give any name also here. So now if you observe here, I am providing the values also at the time of declaration. Okay, so declare the parameter name, and I am selecting data type of the parameter. I am providing the value also. So at the time of declaring the parameter, you are providing the value. Okay, so this parameter is called as local parameter. Generally we will call this as local parameter. So why I am not going in depth here is generally local parameters, this kind of types we never use in the latest version, but in this version by default every parameter is local parameter. That means if you don't provide any value here, it won't accept. You can see some kind of to do queue here, yellow color you can see, right? So you can see some error because this is called local parameter by default. How to convert this local parameter as formal parameter? So there are two kinds of parameters. Even if you see in the Java language also, there are two kinds of parameters. Formal parameters you can see, and some local parameters you can see. Local parameters in the sense you must provide the value at the time of declaring the parameter name. Okay. Formal in the sense you can provide the value at runtime. At runtime you can provide the value. That is called formal. Okay. In the latest version, every parameter is formal parameter only. Every parameter by default. You need not worry about these types. Okay, in the latest version by default every parameter is formal parameter only. Even if you pass the value or if you don't pass the value also, at runtime it will prompt you to provide the value, right? So now I want to practice in this version these parameters. I want to show you the properties, how to convert this local into formal. Okay, select the component name, right click on the component, click on details, click on details. You can see parameter details. Name is parameter name. Scope you can see as local and formal. Local means you must provide the value at the time of declaration. Everything is local parameter here. But when you select the formal option here, formal option, everything is formal parameter. Even if you don't provide the value also, you cannot see to do queue here. You don't see to do queue. You can provide the value at runtime. Okay, so I am not providing value for this parameter alone because I just want to show you the runtime window also, how the graph show the runtime window. You can see indicator also. This is called formal input value, input parameter. You can provide the input at runtime. This is called local parameter. So I am just repeating, in the latest version everything is formal parameter only by default. You need not go and select the details also. Okay, so if you see the other details also, you can see other details like kind. You can see this one. Interpretation is important, so these two I will discuss after this. Let me complete the this one first. I will come back to details later. Again I will show you the details also. Actually this one we have to discuss in the latest version. You will get clear idea, but here there are some differences actually. Anyhow we will discuss in the latest version also. Now I declare the parameter, I pass the values also, right? Close this one, save. Okay, so now these parameter values you have to provide here, right? So now you need not provide the path. You should not provide the path here. What is the parameter name you want to refer to? The input file 0 is this one, in 0. Okay, so this parameter name you have to uh, provide here, right? So if you give value like this, how my component understand this is the parameter? It can be either file name or parameter also. How can my component understand? That's why whenever you are referring a parameter, how you refer the parameters in the unit scripting. If you want to display a value in the unit scripting, you will use echo $a, echo $b, and so on. In the same way here also, dollar should be prefixed for the parameter name to be referred by the component. Now, okay, use dollar here, dollar in 0 file. This is the parameter passing. Okay, apply. Okay, to pass a parameter here. Okay, open this one. Here another parameter we have to pass, right? Open this one, in one file, copy this one, paste here, in one, apply. Okay, join. key should be parameterized. Don't provide the key here. First ID. Okay, copy this parameter name, use key as dollar group key. Okay, xfr also should be parameterized. Dollar, what was that? Join underscore xfr. Provide the parameter. Okay, everything is parameterized here. I think this is correct only. We'll see. Mm, okay, coming to roll up. This is also you can provide ID or you can provide uh, dollar RLP underscore XFR roll up parameterization. So this is dollar underscore out file. Okay, apply. Okay, run the graph. You can see formal parameter alone. You got it right. Since when I click on the run button, since this is a formal parameter, you can see one window here. This is prompting you to provide the value for the group key. Okay, if I made everything as formal parameter, edit parameters, 1 minute. Okay, I'm back. Yeah, so let me make everything as formal so that you can see all the parameters in the runtime editor. Okay, but remember, in your versions you need not do this one. Everything is formal only by default. Okay, so this one I am also making as formal parameter, and this one I am also making as formal parameter, and this one also formal parameter, this one also formal parameter. Okay, so now let me save the changes, run the graph. You can see all the formal parameters, right? You can see all the parameters here when you click on run button. Provide the value for all the parameters. Okay, provide the value for input file, everything like how I provided in the editor, the same way I can provide. Right, in zero file, this is in zero file. Okay, in one file, copy.
Vivi?
Yeah,
Like when we are running this same graph using Unix script, at the time what we will do? Any command is there to pass the parameters?
yeah, I will come to that point. So generally we don't pass like this. Okay, I am coming from step by step actually. Right,
Oh,
this
okay,
one
okay.
we need not learn also. I'm just want to make you, so what is the drawback here, so when I have to go for next step
Okay,
to make you understand. Okay,
okay.
so I will come to that point as well. The output file, I'm providing the path. Okay, so here, yeah, I provide all the values, right? So when I click on OK button, my graph will done with these values. Okay, I'm clicking on OK button here. Okay, my graph is running with these values. Okay, let's wait. I think in the key parameter it may fail. Running, running. Okay, so your question is valid question actually. So since you have some experience in the parameterization, you asked a good question. The thing is, so it is very difficult to provide the values at runtime like this. So as I told earlier, so why I am going for this process is, since I am reading the multiple files from multiple sources to apply multiple transformations, I am parameterizing my graph. Okay, for the single parameter I can provide the multiple values by running multiple times. I ran for only one source, now I provide only one source value, right? So now if I want to run the same graph for another source, again I have to click on the run button, again I have to pass the um, few more values, click on OK. Third source also run third time, provide third set of values. Fourth source run fourth time, provide fourth set of values. Okay, so like if you are running the graph for testing purpose, you can play like this. But the thing is, you never run the graph manually in the production. Okay, in the production you don't provide the inputs like this, so automatically you should be reading the set of values for the first source, you should be running for those values. Okay, and again for the second source also, third source also, and so on, right? So now if you want to run the graph like this for multiple values, this is very difficult to provide the input values at runtime manually. That's why what we can do is we can save all these set of values in a file which is called parameter set file. Okay, how you are able to save the DML record format in a file, Xfr transformation logic in a file, graph in a file. In the same way, these parameter values also you can save in a file which is called file name.pset. Some other file, some file name.pset. The pset is the parameter set actually. Set of parameter values we can save in a file. So you never touch the graph. After saving the parameters in a file, you don't touch the graph. You will just run the file only. Your parameter set file you can run. Your file internally calls the your graph, okay, by passing the values which are available in that file. You will run the files, you don't run the graphs. Right, I will come to that point also. So this graph has failed in join. Like I think the problem with the key. Let me see. Join testing file or directory. Failed seeking access. No such file or directory. Why if it is not able to get the file path? Okay.
I think you gave key for URL in the declaration, maybe.
Yeah, URL only we have to provide.
For key also, that
No,
key.
not the graph got failed file only. It is not able to find out the file it is saying. This file is not.
Oh, input.dat. Okay.
It was there actually. I don't know why it is not pointing. Okay, it was there. So might be this is this exercise graph, right? So it is not able to get the value. Okay, so like you can do one thing. So give any value give any file which can be accessed actually. The graph will definitely you can also exercise this one, practice this one. So create a new graph, parameters everything, provide the input values, run the graph. Okay, provide the path which can be accessible. Here my path is not able to not like accessible by this component. So might because this is using some parameter, right? That's why it is not accessible. I have to save the file in some other directory, then I can pass the value. I should not provide this AB function. I can provide some other value. That's fine. You can also practice that. See, the intention here is when you click on the run button, you can see this set of values here. Okay, so in the real time what you have to do is you have to whenever you parameterize the graph, right? So what you can do is click on the run button or press F5 button. Both are same, right? You can press F5 or click on the run button. Don't click on OK. Okay, provide the values here, right? Provide the values here. Okay, after providing values, this is for first source. Assume for the first source I am providing the values here. First source file path, okay, first source group key and join xfr and all. Okay, go to file menu, click on save as because the pset concept is not available in this version. Psets were introduced from 2.14 version onwards. Here we don't have any pset concept. If you want to work on the reusability in this version, you have to click on run button multiple times. There is no choice, right? But from 2.14 version what they did is in the file menu they have given one more option called save as option. Click on the save as option. It will open a window like how it open the window for graph saving, xfr saving, and it will open a window. Save these all the values in the sandbox pc directory. Okay, in your sandbox how you have all these folders in the same way. In the latest version you can see one more folder called pset folder. You can see in the latest version. Okay, so the pset folder you can save the all these parameter values. Click on save as button, go to your pset folder. Okay, use some file name dot pset. File name in the sense your source name. You can give any understandable name. File name dot pset. That's it. One pset is created. Again edit the same values. Edit, pause second source values here. Go to file menu, save as second source dot pset. Like that you can save n number of pieces for the single graph. Any number of pieces you can create for a single graph. Okay, so any number of pieces you can create for a single graph, right? So now you have all the pieces, okay, in the sandbox. Let us suppose I have okay I have pset. First pset is like us underscore source dot pset. Okay, this pset contains all the values for this parameters. Remember, this pset you cannot understand from the backend. If you fire the cat command on this pset, cat space file name dot pset, you cannot understand the values. It will display values actually, but it is very difficult to understand. That's why always the pset can be opened from the GDE only. If you open the pset from the GDE, the pset can be opened like this in the editor. You can see all the values here. Okay, so you can create UK underscore source dot pset India underscore source dot pset. You can create like this. Now if you want to run this pset, what you can do is from the GDE, if you want to run, you can open the pset like this, click on OK button. Now your pset's values will be passed to the generic graph. The graph will be running with these values from the GDE. It will open the graph also. When you open the pset from the sandbox, right, your sandbox will be opening a graph by default for the pset. Okay, so in case if you want to run from the backend from the Unix session, right, from the backend, if you want to run the graph or pset, the command is same. You can use the air command, air sandbox run. We'll discuss about the commands. Air commands are EME commands actually. Air sandbox run, you can give your graph name, or air sandbox run, you can use your pset name. Okay, both are same, right? We'll discuss about this command. Okay, so now you can run the multiple psets at the same time also. Let us suppose I have 3 psets here, right? I want to run the 3 psets parallelly from the backend. How can you run? Air sandbox run the first pset. You can provide the, okay, first pset, give ampersand, right? Because we already discussed about this background command. If you remember our Unix session, there I told you about ampersand. If you want to push the current education command into background, and if you want to run one more command, use the ampersand symbol. The same thing you can apply here. Air sandbox run, okay, first pset name. So while it is running parallelly, you can run one more pset also. Like this, you can run parallelly multiple psets. This is called using the same application multiple times for multiple purposes. Okay, the same generic graph can be executed multiple times parallelly. Instead of designing the multiple graphs, you can design a single graph with the parameters. Okay, so this is also a bit difficult actually to run all the commands parallelly, bit difficult from the background. That's why, okay, so we are not going with this kind of running nowadays. So many of the providers are going with the new concept called conduct it or plan it. Both are same, right? So conduct it or plan it is there, right? So we are going to discuss about this tomorrow. You cannot see at all 3.0 only, you can see this option. You cannot see at all in this version. I will give some theoretical idea tomorrow. I will show you the practical example when we meet. Okay, so conduct it, plan it. So in the conduct it, you need not write any commands. Air sandbox run commands you need not write. You can just drag and drop the components in conduct it. You can point to the psets. I will show you that. The concept today we understand is about the generic graph and pset only. So in the interview point of view, they will ask what is pset and the purpose of the pset. Okay, a pset is the collection of parameters only. Collection of parameters. Okay, and their values. Right. Okay, so a pset can be created for the generic graph. For the generic graph, the purpose of the pset is when you want to run the same graph for different purposes, by reading the data from multiple sources, by applying multiple transformations, by loading into multiple tables or target systems. Okay, you can create the pset for the existing graph. You can explain practical example also, I mean practical definition also, that is your choice. You can explain any definition, but the thing is the definition should be concluded with the reusability purpose only. So why the psets are introduced for reusability purpose? Okay, so the best example you can say, like if you have 4 kind of sources, from the input 4 graphs you need not design. You can get a new, you can create a new graph like which is called generic graph. My graph contains all the parameters. The parameter values I will pass at runtime. These values I will save in the psets. For 4 sources, I will create 4 psets. These 4 psets I can run from the backend, okay, using air sandbox run command, or I can use the conducted feature also. Conducted we will cover next. So any questions you have in these psets? Because tomorrow what I will do is I will show you some screenshot in the conducted, and I will show you how to run the multiple psets. By tomorrow, like we will be done with this psets and all, right. I will talk about the
So,
m commands tomorrow.
okay. How does it identify like which graph this pset is? So those are internal mappings within that saved pset, right? We
Exactly.
don't want
So
to
your
discuss.
pset, whenever you are saving the values for the pset, right? So you are opening the graph from the GDE. On the graph only you are modifying the values and they were saving. Internally, your Abinitio cooperating system will create a built-in parameter called prototype. Okay. So your
Okay.
parameter prototype will be pointing to base graph actually. That's why
Okay.
it can understand that. You need not worry about that because you don't see the parameter also here generally. But in case if you want to see the parameter value, like if you have some thousands of pieces, because in some of the projects you can see 2000 pieces also. Okay, if you
Okay.
are working on the production support project, in case if you don't have GDE access, you are working on the backend on the Unix server only. In that case, when you open the sandbox from the backend, like using some LSF and LRT command or some other command, you can list down all the objects in the sandbox directory. Then you can see thousands of pieces, for example. In that case, so you have to identify which piece it is pointed to which graph. Generally, the pset name should contain the graph name also. That is the standard actually. The standard is
Okay.
you have to save the pset name with the graph name. That is fine. No one will follow. I mean, some of the guys will follow standards. No, some of the guys will follow. Like we won't follow standards. There is like you cannot give assurance like everyone will follow standards. That's why
Okay.
if you see the pset name itself, if you are not able to identify the graph name, just use the cat command on the pset, cat pset name or some head pset name, or use some command on the pset name to display the contents. There the first parameter is called prototype actually. The prototype will point to the graph name. That is a built-in
Okay.
parameter actually. You don't provide any kind of prototype. Your pset name will contain the built-in parameter called prototype that will display the graph name to which the pset is pointing to. Okay.
Okay.
So like this also you can identify the pset name to which it is pointing to.
Okay.
Okay, that is good question actually, because some of the guys will ask in the interview, if I ask suddenly you, so how can identify the what is the base graph for the pset?
Okay. Very first
Okay,
parameter is called prototype, right?
yes,
Yes.
prototype.
Divi, I had a one doubt a very long time.
Dinesh, one
This.
minute, Dinesh.
Okay.
Okay, yeah, Dinesh.
See, whatever we run runs on the cooperating system. So this R sandbox commands, everything will be executed in the cooperating system, right? Cooperating system. So anyway, we know that cooperating will not be there in the server where we are working or where GDE is.
Yeah, GDE is on
Cooperating
your
will be in a
local
different.
desktop only. There is your local machine only, your laptop or desktop. Okay, but
So where do you run these commands on the GDE server or the?
no, GDE there won't be any separate server. GDE is a kind of desktop application, right?
Sorry. Yeah, yeah. I'm not saying like we have separate cooperating server, right?
Yes,
Like
ETL server.
we connect our GDE to that cooperating,
Yes.
but in order to run these commands, Unix commands,
Yeah.
where do we run? In
In the
cooperating.
ETL server actually. So ETL server or Unix server are both are everything is same actually. Your Unix server. So whenever you install Abinitio cooperating system on the Unix server, that will be called as coop server only. Okay.
Sorry.
Same thing we will call as ETL server. ETL means ETL application server, right? So you will be interacting with the ETL server, right, using some putty or some other terminal. Generally, we will be working on the putty only to interact with the Unix. Okay.
Oh, okay,
So there
okay.
will be executing these 8 commands. So wherever executing Unix commands, right, cat command, ls command, in the same location only we will be executing m commands or air commands, everything. So
Okay.
we'll discuss about that because air command session we haven't started actually. So EME concepts when we discuss, right, then we will talk about the Abinitio air commands.
So as of now, the CTL service is only co-op server.
Yes,
Yes,
yes.
yes.
ETL means general term actually. ETL in the sense any ETL. If any ETL tool is installed on the server, the any server, that is called ETL server.
Okay. Actually, only the GD will be on our machine.
Yes.
Then the server will be somewhere like
Yes.
another.
Yeah. So server will be located over your client location. It can be either India or US or UK, wherever it may be. You will be connecting to the server, okay, through putty.
Actually, in real time, we'll be working on this Windows the machines or Unix machines.
See, you will be working on Windows machine, okay, but you will be connecting to
Okay.
Unix machine from Windows.
Through putty.
Yeah, through putty.
He will be in Windows machine.
Yeah,
Yes.
because not only GD, your MS Excel, MS Word, okay, Abinitio GD, Oracle SQL developer or Teradata developer, right? So
Everything.
Notepad
Okay.
plus plus, everything will be in local desktop only, right? So you'll be working on all these softwares, all these application on your local desktop only. Okay, only to connect to the remote server, which is called your Unix server or ETL server or Abinitio server, whatever it may be, you'll be using the putty session. Okay. So any other questions?
No.
This record session is important for you because you don't have a chance to practice in this version, right? So just go through recording session once today. Tomorrow I will just discuss about because there are some properties also in the parameters. So properties for each parameter we have to discuss what is the properties, how to set the properties or attributes, and how to make the parameter the optional parameter, and how to call this piece from the conduct it. I will discuss all these things tomorrow.
Okay.
This one will be important for interview purposes. Presets.
Yes, pieces are very important actually. So like not only for interview purpose, in the real time also definitely we'll be working on the pieces. As of my knowledge,
Okay.
many of the projects are going with the pieces. There are very less number of projects are not using pieces because you cannot design hundreds of graphs, but you can design hundreds of pieces for the same graph. Okay.
I think yesterday he was not using pset, right? I saw some transformations in his
Yeah, they are not
code.
using PCs. Their version, I think, their version also won't support PCs. They are using some other old version. I forgot the version name. They are not using PCs conducted. They are not using some lookup concepts also. They are using old version actually.
These wrapper scripts, everything. So using wrapper script also we can run this
Yes.
inside that script even. We
Yeah,
can give
yeah,
this add sandbox commands, right?
exactly. That is wrapper in the sense combination of your existing self scripting as well as ab initio commands. Right. So
Okay.
wrapping up of your existing script or your Unix support script with the ab initio commands is called wrapper script. Okay.
Okay.
So you have a script which is checking for the file existency, file renaming activities or file moving activities. So in between some statement, I am calling ab initio graph to run the graph. You can call aid sandbox run graph name dot mp, or you can use aid sandbox run pset name dot pset. So I am just
Okay.
calling the pset graph from the existing script which is called wrapper script.
Actually, I saw one question like, could you please tell the wrapper script which you used in your project,
Yeah,
or
yes.
could you please?
Yes, so we will discuss that. I mean, in the interview questions, right? So I will give some example
Yes.
for the wrapper script.
Okay. Okay, Devi. Chalo. Bye.
Yeah, thank you. Bye.
Bye.